Assalamualaikum and good morning. First of all, thank you to our lecturer for giving us the opportunity to present our project today. Our presentation is about the compilation assignment, chapter 1 until chapter 7 for circuit analysis. The objective of this project is to apply theoretical calculation and compare them with simulation results. Proves the project, we analyze different types of electrical circuits and verify whether the manual calculation match the simulation outputs. The topic cover include circuit variable and elements, resistive circuit, circuit analysis, network theorem, first order circuit, and AC circuit. To verify our answer, we use simulation software such as LT-SPICE, Tinkercad, and MATLAB.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farin Iskandar bin Muhammad Faizal. My number metric is AA250162 and I will tell you about our goal of the project. First, to apply fundamental circuit analysis technique to solve electrical circuit problem, to analyze DC and EC circuit using appropriate theoretical method, to perform circuit simulation using an LT, SPICE, Tinkercad and MATLAB, and to compare theoretical calculation with simulation result to verify accuracy.
Before we start, let me introduce our group members. My name is Afia Haikal, AA251378, and I am one of the presenters for today's presentation. Our group members are Faharin Iskandar, Amir Zakwan, and Fidaus. Now, let's move on to our presentation. Now, I will explain the manual calculation for this circuit. First, we obtain the voltage and current values for each circuit element, labeled from A to F. Next, we calculate the power for each element using the formula power P equal voltage by multiply current, or P equal VI. For example, element A has a voltage of negative 18 volts at a current of negative 51 amperes. Therefore, the power is 980 watts. For element B, the voltage is negative 80 volts and the current is 45 ampere, giving a power of negative 810 watts. The same calculation was repeated for element C, D, E, and F until all power values were obtained. In this table, positive power means the element absorbs electrical power, while negative power means the element supply electrical power to the circuit. After calculating every element, we compare the total absorbed power with the total supply power to verify the law of conservation of energy. From the result, we found that the total power calculated manually is consistent with the circuit analysis, which confirmed that our calculations are correct before comparing them with the simulation result. Next is the comparison between manual calculation and simulation. Manual calculation requires us to solve the circuit step by step using mathematical formulas. Although this method improves our understanding of circuit analysis, it takes more time and is more likely to have human calculation errors. On the other hand, simulation software provides results much faster. It reduces calculation mistakes and makes circuit analysis more efficient. For example, in Chapter 1, both methods produce the same total resistance of 10 ohms and a source current of 0.5 amperes, proving that the manual calculation was correct. Overall, manual calculation help us understanding the theory, while simulation help us verify the result quickly. On our project, most of the simulation result match the manual calculation. This showed the analytical principle we applied were correct and the formulas were used properly. However, in some cases, there was small difference between the manual calculation and the simulation. This difference may be caused by incorrect component values, difference of phase setting, rounding errors, or incorrect polarity and sign convention. Therefore, it is important to double-check both the calculation and the simulation setting before making conclusion. Using both methods together gives us greater confidence in the final result. In conclusion, this project helps us understand how theoretical circuit analysis is applied in practical situations. Manual calculation is important before it strengthens our understanding of analytical concepts and problem-solving skills. Simulation is equally important because it saves time, reduces calculation error, and verifies the correctness of our manual work. Therefore, combining manual calculation and simulations provide a more accurate, reliable, and efficient way to analyze electrical circuits. Thank you for your attention. That is all from me.
Assalamualaikum and good day to everyone and to my beloved, to my respected lecturer. Today taking you through our analysis of DC electrical circuit, comparing manual calculation and simulation calculation. For the chapter 2 basic resistive circuits, to find the total current coming from our power source, our very first step is to simplify the resistor network. We'll begin by identifying two resistors in series, a 4 ohm and a 6 ohm resistor, which combine to give us 10 ohm. This equivalent resistance sits in parallel with another 10 ohm resistor. Using the parallel resistance formula, 10 times 10 times 10 divided by 10 plus 10, the parallel resistance formula gives us an equivalent parallel resistance of 5 ohm. So adding the remaining 5 series resistor, we find our total circuit R total is exactly 10 ohm. For our next part is the comparison. So as you can see, the comparison for the manual calculation, when V is equal to 10, our current will equal to 1 and our power will equal to 4. While in simulation we use 1 volt and the current will go 0.25 ampere and the power is 0.25 watt. Secondly, for the analysis method, so for the manual you use step-by-step formulas. As I said before, we use each step for the parallel system formula, and then for the simulation we use circuit simulation software. So for the accuracy of our circuit lah, for the manual it's accurate but may have human error because we are human, so we all do error. So for the simulation it is accurate and faster because we use technologies. The next slide is for the discussion and conclusion. For the discussion, this study compares manual calculation and simulation for a DC circuit. Second, the manual methods use basic law like Ohm law and resistance rules. The simulation provides faster and easier circuit result. Comparing both methods helps check accuracy and find errors. So by using both methods, improve understanding and give reliable result. So for the conclusion, manual and software calculation give the same result. Total resistance is 10 ohm and source current is 0.5 ampere. To chapter 3, we scale up to a more complex multi-loop circuit. For this network, we utilize mesh analysis derived from Kirchhoff voltage law, or as we all know, KVL for the short form formula lah. We set up simultaneous equation for 3 distinct loops. For the first loop is the as you guys can see, here is the loop. To solve this system efficiently, we convert this equation into a matrix format like our lecturer Madam Azliza teach us to do. So solving by using the matrix much easier lah. Just put down the calculator. Just input the value at calculator. Therefore, we got our result for the I0. It is which equal I1 is 4.29. Comparison part, we go through this. For the we got three like before lah. We got output, we got analysis method, and then we got the accuracy. So as you guys can see, the output for both calculation, we got same 4.29 milliampere, same as for the simulation. For the analysis method, for the manual, use mesh analysis, which is Kirchhoff voltage law, and for the simulation, we use the software lah. So accuracy, it is accurate, but depends on the correct calculation. If we got slightly error at the calculation and then boom, we got wrong. So for the simulation, it is accurate and match the manual result. For the chapter 3 discussion and conclusion, manual mesh analysis and simulation both give the same output current, which is 4.29 milliampere. This confirms the correctness of the manual Kirchhoff voltage law calculation. Manual analysis is accurate but require more step than simulation lah. Simulation is faster and easier. So the conclusion, both method can be used for circuit analysis. For the conclusion, manual method is accurate, but manual method take more step than simulation. Simulation is faster and reduce calculation effort. So manual calculation will always have human error. Not always have, but the percentage of having error is bigger than the simulation calculation. So that's all from me. Thank you.
Now I will continue to chapter 4, which is a network theorem. As you can see, here is a manual calculation and the simulation. Here is a comparison of manual calculation and simulation. The output that we get is same value, and analysis method that we are using is for manual is a nodal analysis KCL, and for simulation we are using circuit simulation using Tinkercad. And the accuracy for the two of this method is theoretical calculation and practical verification. With accuracy with a manual calculation maybe have some human error, but the simulation is perfect and doesn't have any error. This is a discussion and conclusion. First of all, I will tell you about the discussion. Nodal analysis was used to calculate the output voltage. Kirchhoff current law (KCL) was applied to each node. The circuit was also tested using Tinkercad simulation. The manual calculation and simulation gave the same output voltage, which is negative 0.125 volt. The simulation confirmed the accuracy of the manual calculation. The nodal analysis is an effective method for circuit analysis. The experiment objective was successfully achieved. Here, the conclusion of this chapter, the output voltage was successfully determined. Manual calculation and Tinkercad simulation gave the same result, which is negative 0.125 volt. The simulation verified the manual calculation. The result confirmed the accuracy of the circuit analysis, and the experiment objective was successfully achieved. Now I will continue to chapter 5, which is a capacitance, inductance, and mutual inductance. Here is the manual calculation and the simulation. Here is the comparison about manual calculation and simulation. First of all, circuit mode. The manual is DC state steady and simulation is transient using bias point. The target value node voltage node equation V equal to VE negative VD. The simulation is evaluate node output metric, and analysis tool method is 2.325 cos bracket 10t plus 90.46 degree ampere. And as you can see, at simulation, we got a 2.33 cos in bracket 10t plus 94.5 degree ampere. The discussion about the chapter 5 is the circuit operate under DC steady state condition. In DC, the inductor act as a short circuit. The capacitor act as an open circuit. Nodal analysis was used to calculate the circuit value. The arcade piece-by simulation match the theoretical analysis, and small difference are due to a numerical approximation and simulation setting. The result confirm the accuracy of the circuit analysis. And the conclusion of this chapter is the DC steady state voltage was successfully determined. Manual calculation and OCAD piece-by simulation gave similar result. Inductor were treated as a short circuit and capacitor as open circuit. Nodal analysis was used to solve the circuit. The simulation verified the theoretical calculation, and the experiment objective was successfully achieved. That's all from me.
Hello, Assalamualaikum. My name is Muhammad Fidaus bin Zulkifli, Matrix AA250751. And today I'm going to be presenting about first order circuit for chapter 6 and AC circuit for chapter 7. I will talk through the theoretical calculation, explain how we model this circuit using simulation software, and compare the two methods to validate our result. Let's begin with chapter 6, where we analyze the first order RC/RL circuit. To determine the behavior of the circuit over time, we applied the standard step response formula, calculating the initial voltage or current, the final steady state values, and the time constant pi. By solving this equation step by step, we obtain the mathematical expression that describe how the circuit responds immediately after we switch changes position. Next, we construct the exact same circuit in our simulation software to observe its transient response visually. By setting up the transient analysis, we generate waveform graph that show the voltage or current changing and discharging over time. We can compare the data point from this simulation graph with our manual calculation. We can see the curve perfectly matches our theoretical expectation, proving our manual analysis is correct. Moving on to chapter 7, we shifted our focus to alternating current AC circuit operating under steady state condition. Here, we convert all component values into impedance and transform the sinusoidal source into phasor domain representation. By applying standard circuit law like KVL, KCL, or nodal analysis in phasor domain, we successfully calculated the magnitude and the phase angle of the target voltage and current. To verify our AC analysis, we simulate the circuit using AC sweep and time domain analysis. The simulation provides us with both the phasor magnitude and the actual sinusoidal waveform, allowing us to measure the peak value and the time shift between the waveform. Just like in the previous chapter, the simulation result align perfectly with our phasor calculation, confirming that our theoretical understanding of AC circuit behavior is accurate. In conclusion, the objective of this study was successfully achieved through the application of theoretical analysis and simulation technique in electrical circuit analysis. The result obtained from manual calculation and simulation software showed good agreement, confirming the accuracy and reliability of this method used. Overall, this project enhanced our understanding of circuit behavior, improving problem-solving skill, and provide valuable experience in using engineering simulation tools. That's all our presentation from Group B7. Thank you.